We're looking at few ways to talk about dielectric, its characteristics, to distinguish a dielectric with another dielectric. So one of the ways of doing that is with electric susceptibility. So what does it do? What does it tell? It talks about how sensitive a dielectric is. Say I have a dielectric. So how easily it will get influenced by your electric field. So it's a property of the matter that tells how easily it can get polarized by an electrical field. Right. Now, when do we measure this? That's a question that we need to answer. When the electrical field is not too large. If it's too large, then pretty much every dielectric, we have a similar relationship, or it's like it has reached its maximum. So you won't be able to study it a lot more. So we are talking about a scenario wherein the electrical field exists but not too much. And then what do? We change the electrical field, that is, we change the voltage a bit and see how the dipolar acts. How much polarization happens for that small change. Okay, guys. Now, what is this symbol? T. That's how you represent your electrical susceptibility. Of course, there is a math to it. So the math is that if we have an external electrical field, say E naught, right, which is not large, then the polarization P is proportional to the net electrical field inside the dielectric. So the net is dependent on what our induced electrical field is, and your net would be the difference between the two. So here, this is your induced electric field. Okay. So sometimes I might write it as induced. So please don't mind. Okay. So here we're talking about this being proportional to E naught minus EP. So when we remove the proportionality, of course, one, it's dependent on the material, permittivity of free space, right? Material itself, and E naught minus EP. So as a definition, it's a dimensionless proportionality constant. Okay, yeah, actually. So this is your G, right, guys? So this will be equal to polarization divided by all of this set of expressions. So T is a dimensionless proportionality constant that measures how much a dielectric material becomes polarized in response to an applied electrical field. Its ratio of polarization to epsilon naught times the electrical fields, right? Electrical field, when we talk about it, is to do with net field, right? Overall field that we're looking at. So let me repeat again. Dielectric is a material which kind of, when kept between two plates, it alters the capacitance of the capacitor. Its capacity to hold extra bit of charges. So we are trying to understand, we are trying to study that. And one of the ways of studying that is looking at how easily can it get polarized. So the mathematical or the scientific term to that is electrical susceptibility. That's it. It's a very simple concept. So it talks about how easily the electrical field can influence the polarization in dielectric. Okay, guys.